This is unit 10.4. 10.4. Let me change the color here. In this unit, we're going to study about inscribed angles. Inscribed angles are those angles with its vertex right on the circle. So that's on the circle with two sides that are chords. So if you look at the diagram on the left, ABC, AB and BC are two chords in the circle, and B, one of the vertices, is right on the circle. And an intercepted arc is the arc that lies between the endpoints. In other words, my arc AC, if you look on here, is the intercepted arc, and that lies between the endpoints of an inscribed angle. The degree of the inscribed angle is equal to half the measure of the intercepted arc. In other words, the degree angle of ABC here is half of the angle measure of the arc AC. Now keep in mind, which one is bigger? Is the arc bigger or is the angle bigger? And obviously the arc is bigger. So if the arc is given, you have to half it to get the degree for the angle. If the angle is given, you have to double it to get the degree for the arc. Okay? And the next point is if an inscribed angle intercepts a diameter, then it is a right angle. And so in this case, in this example on the left-hand side, angle BAC right here equals 90 degrees. Now take a second to understand why that is the case. Remember, we said if the inscribed angle intercepts a diameter, so here's my diameter, right? And a diameter is a special chord because it faces this arc. And arc BC is half of a circle. So this arc, I'll write it here, arc BC, the measure for that is 180 degrees. And since angle BAC is a inscribed angle, therefore it's half of 180, and that's how we drew the conclusion that the angle measure for BAC is 90 degrees. Finally, if two inscribed angles intercept the same arc, the angles are congruent. Oops, I keep touching. So congruent. And in this case, AD right here is the shared arc. Therefore, angle ABD and angle measure ACD are exactly the same. Okay, so three concepts about inscribed angles. Just a quick review. One is the angle measure for the arc inscribed angle is half as much as the arc measure, and also when an inscribed angle intercepts a diameter, that means it's a right angle. And thirdly, overlapping arcs have, the angles that faces the inscribed angles that intercepts the same arc, they have the same degree measures. So let's take a look at how we're going to use this. Number one is fairly easy. We have an inscribed angle, right? And if the arc that it faces is right here, it's 62 degrees. So angle WXY has to be half of 62, which equals 31 degrees. Okay? Now, notice that in the last unit, we learned about central angle. That has the vertex being in the center. So this degree in the red, so angle Z, the angle measure for Z would be exactly 62 degrees. but the inscribed angle of WXY would be half of that at 31 degrees. So second problem, we've got an inscribed angle at 113, and it's asking for the arc measure of DGF. Oops, I didn't do a good job there. See if I can redraw this. Sorry about that. See if I can redraw this part. There we go. That's much better. So this part obviously is facing this angle, and the arc is the larger angle. So it's 113 multiplied by 2. I should have 226 degrees. Number 3, I have PQR. I'm looking for PQR, and right here. Now PQR is facing the diameter, therefore it's facing half of the arc, and that's 90 degrees. That's what we talked about earlier. I'm gonna skip 4 and 5, and then let's look at number 6. I have I'm asked to find angle measure for RST. RST is right here. That's what I'm looking for. And then the other angle is RUT. RUT is right here. And notice these two angles face the same arc. So I just need to find that arc, and because they're inscribed angles, I divide that by half, I would have it. So I know I have 64 here. I have 64 here. I have 139 here. If I keep going, I have 175 there. So if I use 360 minus 64 minus 139 minus 75, I would have the red part. And that should give me 82 degrees. 82 degrees are here. And then if I half that, I should have 41 degrees for both angles because they face the same arc. Okay? Now let's look at some algebraic calculations. I'll skip 7 and 8. They're relatively straightforward. Let's look at number 9. I have an angle right here at 13x minus 1, but this angle, it's facing the, intercepts a diameter right here. That's a diameter. So we know the setup would be this angle has to be 90 degrees because diameter faces half of the circle, which is 180 degrees, right? So half of that is 90 degrees. And that should give us, let's see, 13x equals 91. X comes out to be 7. Okay. Number 11, I'm solving for x here, and I need to look at this angle. And obviously, I've got 92 here. I've got 162 here. So 360 minus 92 minus 162 should give me 50, what's the answer there? 106 degrees. So 106 is this red part. That's 106 degrees. And then the rest of it, it's easy. It's just setting up the equation at 7x minus 10 equals 106. And the x should come out to be 9. That's my final answer there. Okay, let's see. Oops, I'm making a mess here trying to erase things and couldn't erase it. All right, let me move my sheet upwards a little so that we can see. Number 13, I have angle FGH over here. I have 6x plus 11. Oh, 6x plus 21. FJH. Angle FJH over here. I have this part. I have 17x minus 28. So I'm asked to find FJH. I'm asked to find FJH, which is this one. So in order to find that, I have to find X first, right? Notice that they, if I use the a different color here, FGH, which is this angle, FGH, this blue part, it's intersecting this arc. And let me change the color to purple. And this one, FJH, it's intercepting this part. Therefore, we've got a connection here because if we add the two together, I have 360. And because I'm looking at inscribed angles, so if I add the two angles together, I should have half of 360, which is 180. That's the setup there. And so I won't solve the whole thing for you. That'll be -7. And but you got the concept. Once you find the X, you plug it back in to find the whole angle measurement for FJH for the arc. And notice again, this is looking for the arc, so it's the bigger angle. It's not just looking for the, if you find the angle measure for the angle, you have to multiply that by 2. Okay, let's look at number 16. I will move it up. It's probably easier if I move it up here. So the number 16 says if angle measure for KJL is here. This part is 3x plus 2. And KLJ over here is 7x minus 32. And we're asked to find the angle measure for KL, the arc for KL. Okay, so really it's also asking us to find 3x plus 2 because that's the angle KJL intersects arc KL. So we have to find some kind of relationships. How are they connected? One thing we know is that if I use red, look at this angle K. It's a right angle because it intersects the diameter, JL, right? Which means that 3x plus 2 plus 7x minus 32. If I add these two angles together, I should also have 90 degrees because triangle gives me 180 degrees, the interior sum. So that's 10x minus 30. Oh, that's easy math there. Equals 90 degrees. X, hold on. X is X is 120. 10x equals 120. So X equals 12. And then what you need to do is to plug it into the angle measure for KJL, which is 3x plus 2. 3 times 12 plus 2, that gives me 36 plus 2, which is 38. And to find the measure for KL, you simply multiply that, and that should give you 76 degrees. Okay, so it's not hard, but it is a lot of steps. But the first, most challenging step is to recognize that angle K is actually 90 degrees because it intersects the diameter. And therefore, the other two acute angles add up to 90 degrees. And then you take your algebra from there. Okay, so not hard at all, but it's a little tricky sometimes. Okay, here is some more practices, but in this case, rather than an inscribed triangle, we have inscribed quadrilaterals. And if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So they add up to 180. And think about why that is the case. In this case, B and D would add up to 180. because angle D faces the arc AC. And angle B, I'll use gold, faces arc ADC, the major arc, right? And because they add up to 360, half of that is 180. So that's the reason why they add up to, they are supplementary and then add up to 180. So same thing goes with angle A and angle C. They add up to 180. And angle D and angle B adds up to 180. So there's not much, this is, a lot of it is just easy practices. I'm going to skip some. So I'll do number 3. If you look at, we're asked to find angle V. In order to find angle V, let's see what else we know. We have 60, we have 51. If 51 is facing the arc, Vx, that means 51 times 2 is 102. 102 minus 67 would give us, let me erase this. That would, so 51 times 2 is 102. Then 102 is Vx, right? Minus 67 would give me Wx. And that would be 35. Is that right? 35. Yep. So now if this part is 35, then the other part is 360 minus 101 minus 67 minus 35, whatever that number comes out to be. So let's look at some specifics. Angle V. Oops, I do have to look at it. So this part is 157 degrees. So angle V faces major arc WXY. And that means if I add 157 with 35, it's 192. Then I divide that by 2, I have 96 degrees. And angle W is 101 plus 157. That's the arc, and then I divide that by 2, I should have 129 degrees. And finally, X is 101 plus 67, so it's 168, and I divide that by 2, it becomes 84 degrees. Okay, so again, it's using all the information, finding all the arc measurements, and then look for the corresponding angles, figure out the relationship. If you have the arc is greater, divide it by half. If you have the angle you're looking for arc, you take the angle measure and then multiply it by 2. Let's do some harder ones. How about I'll do number 7 here. Number 7, I have to solve for X. What can I do? I have 135, I have 91 here. And okay, so I know this part, right? So so if I just add 91 plus 135, I should have 135 plus 91. My calculator tells me I have 226, which means the angle measure for ONM should be half as much, which is 113 degrees. And if this is 113 degrees, the opposite angles should add up to 180. So 15x minus 23 plus 113 should give me 180 degrees because they are supplementary angles. And if you figure that out, x should equal 6. Okay, so this is probably the most challenging as I can see. The others are fairly easy. It's just opposite angles are supplementary. You find the relationships, set up your equation, and use simple algebra to find your x there. So if you have any questions, come and see your teachers whenever it's convenient for you. I know this is the end of the year. It's the fourth quarter. You have a lot going on, but make sure that you understand the concept. It makes life a lot easier. All right, guys. See you in class. Bye.